Hello, everybody, and welcome to a rarely done now podcast on ionic nomenclature. So, nomenclature means naming. So, we're going to learn how to name the ionic compounds this time. Right? Ionic compounds are made of positive cation ions and negative anions. So, you should be aware that there are two types of ions, and it's kind of hard to keep track of which one's which, right? But a cation, I remember that cats have pause, right? So cations are positive and anions are negative. Oh, that's kind of boring. Positive ions and negative ions are found in the periodic table. So the ones we're going to use are +1, +2, +3. This right here I always call 0. -3, -2, -1, 0. Okay, so there are a few other ones that are always in here. So notice the D block basically is not, you don't know what the D block is. We'll get to that in a little bit. Okay, the ones that are blued out, you don't need to worry about that much. That just means they're weird little ducts there. But basically, what you need to know is first column +1, +2, +3, 0, -3, -2, -1, 0. All right. NH4 is the only other positive ion we will use that's not from the periodic table. So there are a few, very few, positive polyatomic ions. The blue region has multiple positive charges that are indicated by a Roman numeral. All Romans for us have a +2 as one possibility. So what this means is there's a couple of choices for each one. So in my high school, there were two girls named Amy Roberts. One was Amy Roberts, and everyone liked this Amy Roberts. It was Amy Roberts with Mountain Dew teeth. And she was the Amy Roberts with the bad teeth. And the other girl was called the other Amy Roberts. Now, there was someone else in our school named Buddy. There was only one person in the whole school named Buddy. We didn't have to say which Buddy. And I think that still happens today. You know, if your name is Danny, we've got, like 30 Dannys in 7th hour. So we've got 30 Dannys. Danny who? Danny K, Danny whoever it is that goes through it. But you don't have to ask if someone has a more unique name. Tallulah is one that pops into my head. So which Tallulah? There's only one Tallulah. So that works. So if you're in the blue region, you have to say which one. So this blue region is the which one region. And I often call it the Roman region. So multiple positive charges that are indicated by a Roman numeral. All Romans for us have +2 as one possibility. So if I'm looking at chromium +3, I identify that as chromium Roman numeral 3. Lead +2 is lead Roman numeral +2. Tin +4 is SN +4. I just do want to say the only one that's tricky, this is 6 and this is 5. In case you haven't had to do Roman numerals before, I just misspelled 5. Negative ions that end in "ide" are on the periodic table. That means they don't have an oxygen attached to it. So we've been working on our ion sheet. Notice there's oxygens attached to darn near everything, right? And those don't end in "ide." Others have to be memorized. So S-2 is sulfide, right? So if it's S2 negative, that's the same as S-2, whatever you like. Sulfate is SO4 -2. Memorize that monster. So the way I remember this is I'd like to have oxygens, but I don't. So I'd like to have oxygens, but I don't. So we know F- is fluoride. Like in teeth, notice there's no oxygens in there, right? We've heard enough sodium chloride, there's no oxygens in there, okay? Ionic compounds have a charge of 0 because their charges cancel out. Sodium chloride, mentioned a minute ago, is an NaCl and not NaCl2 because the charge is balanced. So those charges balance, +1, -1 equals 0, and that's what we're looking for. Barium chloride is BaCl2. Barium is +2, so it takes 2 of these to cancel it out. So Ba +2, Cl -1 doesn't cancel. Another Cl -1, oh, hey, that cancels. And if I was a fool, I could write it like that, but it's so much easier to write BaCl2. So this tells me I have 2 of them. Aluminum chloride is Al +3, Cl -1. And how did I get the Al +3? Here's aluminum. And chlorine, same thing. So here, notice, I'm going to show you a little shortcut here. after you do a bunch of these, you start to notice that, oh, it takes this charge down there, 3, the number, not the negative, there. Magnesium oxide. Magnesium oxide. Magnesium plus 2, oxide minus 2. They equal each other, right? So if they equal each other, it's Mg. Oh, Mg plus 2, O minus 2 equals MgO. Notice, don't leave those charges hanging. Sodium oxide. We've done this. Sodium is plus 1. Oxide is minus 2. So then we have Na2O. Aluminum sulfide. This one's tricky. Aluminum is plus 3. S is minus 2. So if you do the little crisscrossing thing, and this works, Al2S3. But let's think about this. So right now I have not enough negative charges. So I'm going to do Al plus 3, S minus 2, S minus 2. So do you see how right now I have negative 4, but I only have plus 3. So I need another aluminum. Well, that didn't get me there. Right now I'm at plus 6. And over here it's minus 4. So I'm going to add another one, S negative 2. So now, plus 6, minus 2, minus 4, minus 6. Now I'm equal. And I have 2 aluminums. And I have 3 sulfurs. And that's where Al2S3 came from. Given the formula, you just name the ions. So AlCl3 is made of Al plus 3 aluminum ion and Cl negative 1 chloride. So it's aluminum chloride. MgO is the magnesium ion and oxide, so it's magnesium oxide. Charges come from the periodic table and the ion list. So that's where those charges will come from. NH42SO4. Ooh, ion list. NH4 positive is ammonium. SO4 negative 2 is sulfate. So it's ammonium sulfate. Okay. Roman metals must include the Roman numeral in its name. FeCl3 is iron. And I look at iron, and iron is like right around here. So it needs a Roman numeral. So I'm going to leave it empty for a second. Cl is minus 1, I know that, and that's going to be chloride. Now, I know chloride is minus 3, right? So Fe is plus something, and I have 3 negatives. So this together is negative 3, so I need this to be plus 3. So one of these has to be plus 3. So that means it's iron 3. So to read what I wrote here, FeCl3 made of iron something and chloride negative. The charge is balanced, so iron's charge must balance the 3 negative ones. Iron must be plus 3 to do this, and that's why it's iron 3 chloride. Yay. So again, just a little visual of it. Cation, anion, remember cations are positive. Okay. Na positive, Cl negative, put them together, sodium chloride. This is sodium ion, magnesium ion. OH negative, again, your ion list is hydroxide. Fun thing here, see how I had to have 2 MgOH to show that properly. I put it in parentheses because I have 2 OHs. Mg is magnesium, SO4 is sulfate, magnesium sulfate. All right, let's do some more examples. Al, aluminum, okay, and then Cl, there's no oxygen, so it's chloride, okay. Na is sodium. Oh, I got oxygens here, so I got to look at it. Eventually you'll have these memorized, but we need this part. With oxygens, it's going to be this guy right here, carbonate. This one has a few extras, so you only need to know the one that I gave you in class. Na is still sodium. Notice we don't change the ending of the metal, right? N is no oxygens, nitride. K is potassium, potassium. O, just one O, so just oxide. Okay, copper 2. So what that means is I'm going to write Cu plus 2. Nitrate. Uh-oh, doesn't end in I, so I'm going to look in my ion sheet. Nitrate is NO3 negative 1. Do you see how it's going to take 2 nitrates to balance a plus 2? Plus 2 minus 1. It's going to be Cu NO3 taken twice. Copper 1 nitrate, pretty similar. Copper plus 1, nitrate minus 1. Notice how my charges equal each other. So just put them next to each other. CuNO3. Okay, notice how the 1 will not have, well, let's say I've got the 2 here. I'm not going to show the 2 on the copper there. Lead 4 carbonate. Lead 4 means plus 4. Carbonate is up here. Again, CO3 negative 2. CO3 negative 2. And you see how to make these charges balance? It'll take 2 negative 2s to balance out the plus 4. So it's going to be Pb CO3 taken twice. So how do I show 2 of these? 2 are parentheses. All right, vanadium. V is vanadium. And then because it's a metal, I got to look and see is vanadium Roman. So I'm looking in the periodic table, and vanadium is right here. Oh, doggies, it's Roman. So I'm going to have to figure out its Roman numeral. So it's V plus something. O, I know oxygen's minus 2. Okay. So vanadium something, O is oxide. So 5, negative 2s means it's negative 10. So 2 times something equals positive 10. So each vanadium must be plus 5. Vanadium 5 oxide. I think that's it. It is. So I will say 2, 2, 2, 2 toodles to you.